Alright guys, so welcome back to this video on SURDS, and in the last video we were looking at basically what binomial products involving SURDS were, and in this video we're going to be going through a few examples from the textbook, the New Century Maths Advanced, from exercise 1.05. So in this one, because there's a lot of questions, we're only going to be doing the last one of all the questions. Okay, so this is question I, sub-question of question 1. Now, as we can see here, they've given us our initial form that we were looking at in the previous video. So we're going to just go through and multiply these two together. So remember, we're getting this and we're multiplying it with this whole thing. So how do we do that? We look at each individual combination. So let's go with the first one, which is 3 root 2 times 4 root 2. So what we're going to do first is we're going to times together the coefficients, so plus 3 and plus 4. So what's that? That's going to be 12. And then we're going to go through and times the roots, okay? So root 2 times root 2 is root 4. Okay, now that probably looks familiar, but let's go through and do the other one first. So what do we got now? We've got a plus 1, remember, in front of this. So 1 times 3 gives us a plus 3, and then timesing the surds, so we get root 3 times 2, which is root 6. So root 4, we know that we can simplify that a little bit more. That's the same thing as 2. So then we've got 2. Remember, there's invisible times here. So 2 times 12 plus 3 root 6. Now, we probably could get that down further, but again, it would just be in root 3 times root 2, which is just as useful as this. So this is probably the more compact form. So what we're going to do is we're just going to times these two together, and that'll be our final answer. So we have 24 plus 3 root 6. Okay, let's get on to the next question. Okay, so we've got question 3 now. Now this is part H that we're looking at here because we're doing the last question. And as we can see, they've given us a different form this time. So we have two brackets that we're going to have to multiply together first. Now the reason that we have to multiply it first is because, remember, we have to follow the order of operations, which we remember through our BIDMAS. So we do our brackets first, then our indices, then our division and our multiplication, and our addition and subtraction. So looking at inside our brackets first, are they in our simplest form? Yes, because these are all prime numbers. They can't be simplified down anymore. So we can tick that off. Are there any indices? So that means to the power of 2 or to the power of 3, blah, blah, blah. No, there's not. Are there any divisions or multiplications? Yes, remember, because there is a invisible times here. So we're going to have to times this with this. So again, we're going to be looking at the individual parts. So to look at the individual parts, we're first going to start off with this combination, which is going to be root 7 times 3 root 5. So remember, there's a 1 out the front of this root 7, so we're going to times the coefficients. 3 times plus 1 is going to be plus 3. Root 7 times root 5, root 35. Okay, now with that combination's done, let's do this one over here. So we have plus 1 and plus 2 coefficients, so timesing them together, we're going to get plus 2. Looking at the roots, we have root 7 times root 7, which is going to give us root 49. Now, yes, you're going to be thinking that looks familiar. We'll fix that up later. Okay, let's get on to this other combination. So now remember, we have a minus 2, so that's going to be important. So we have minus 2 times 3. What's that going to give us? Minus 6 root 5 times 5 is 25. Yes, it's familiar. We'll fix it up later. Now our last combination, which is going to be minus 2 times 2, is going to give us a minus 4. And we're going to look at our root 5 and root 7, which is going to give us root 35. Okay, so let's clean this up a little bit. Okay, so now we have our expanded form, so we're going to simplify this to make it a bit easier for us. So let's look through these surds, see if we can see any easy ones, and we can see root 49 should stick out to us, and root 25 should stick out for us. So we know that root 49 is the same as 7 and root 25 is the same as 5. So remember, when there's nothing in the middle, that stands for times, and we do our times before we do our pluses and our minuses. So let's go ahead and do all our times. 3 times root 35, we can't do anything there, so we still have 3 root 35. Okay, 2 times 7 is going to give us 14. Okay, and then we have minus 6. Remember, there's a minus in front of that. And plus 5, so that's going to give us minus 30. And then this minus 4 root 35, we can't do anything there. So minus 4 root 35. So our next step that we're going to do is yes, we could do this one right now, but we'll save that until later because we can group together our like terms. So there is no root here, so these two are going to be like terms, and these other ones here, because they both have a root 35, remember you need to have the same root in order to plus or minus these two. So they do have the same root, so we are allowed to do that. So 3 root 35 minus 4 root 35. So let's look at our number line. Remember, this could always trick us. We've got our 0, 1, 2, 3. We have our 3, and we're minusing 4. So when we're minusing, we're going towards negative infinity. So I'm going to take 4 steps. 1, 2, 3, 4. And we have negative 1. So we have negative 1 root 35 for this lot of our like terms. And we have 14 minus 30. Now again, you're going to have to look at the number line and realize, okay, so this is 0. This is going to be 14. So 14 minus 30 is going to give us minus 16. Okay, and there's nothing extra. So this is going to be our total answer. Remember, we could rewrite it if we wanted to as minus 16 minus root 35. Because just simply having a minus, remember, we don't need to write this invisible one. Okay, so what we're looking at now, this is question 5, part H in the textbook. So, as you can see here, they've given us one of our special cases that we looked at in the previous video. So, what does this squared mean here? It means we're going to times it by itself. So this here is just short for writing this. Now this is going to be more familiar like we did in the last question. Okay, so that's what that's short for. And then we're going to try and times this by this. So what do we have to do? We have to times each of the little parts in the middle. Remember that this here is short for times. So let's get started with the first one. So we're going to multiply our coefficients first. We've got a plus 2 and a plus 2. So it's going to give us 4. A root 5 and a root 5 is going to give us 25. Okay, our next combination is going to be, okay, 2, because that's a 1, remember. Okay, and root 15. Okay, let's go into this combination. We have a 1, invisible 1 out the front. So 1 times a plus 2, which is going to give us plus 2. Root 3 times root 5 is root 15. And our last combination over here, we have 2 plus 1, so it's going to be just a plus 1, root 9. Okay, so we've got it in its expanded form now. So what we're going to do next, we're going to try and group our like terms whilst also trying to simplify it. So let's just look at our simplifying first. So I can straight away see that this 25 here can be written as 5 because it's the same thing. So we can rewrite this bit here as 4 times 5. And this over here, root 9, is the same thing as 3. Okay, and that's an invisible 1, so just 1 times 3 is 3. Okay, so we can now go ahead and do these middle bits, which have a like term of root 15, and they both have 2. So in total, we have 4 lots of root 15. So simplifying this whole thing, we have 20 plus 4 root 15 plus 3. Now we should think to ourselves, can we simplify this any further? Do we have any more like terms? And we can see that these here are like terms because they don't have an extra root attached to them, so we can handle them. Now we should also be thinking, can this 15 be simplified into anything better? So we think about our factors of 15. Does 15 have a square number that can create it? So I think 15, its factors 3, 5, 15, 1. None of these are square numbers, so it's safe to just leave it in 15. If it had something like a 9 that we could have taken out, then we would want to take out that 9. Okay, so our question 8. Now this is part F because it's our last question of question 8 in the textbook. So what have we got here? We again have a similar form to what we had before. So remember, this is simply short for 3 root 10 minus root 2. And then again, 3 root 10 minus root 2. And there's, remember, the times in the middle. So we're trying to times this with this, so we've got to take the individual parts again. Okay, so I'm going to go right ahead and I'm going to multiply these through. So I can see that I've got a plus 3 and a plus 3 is my coefficient. So I've got 9 root 10 times root 10 root 100. Yes, it's going to look familiar. We'll get that in a sec. Okay, our next combination is going to be minus 1 root 2. So remember, you got your invisible minus 1 at the front times a plus 3. So minus 1 times plus 3 is going to give us minus 3 as our coefficient. And 10 times root 2 is root 20. Okay, it's an ugly 20, sorry. Let's go into this next one. So we have, again, a minus 1 and a plus 3. So it's going to give us another minus 3 root 20, looking at those surds. And then our last bit here, we have a minus 1 and a minus 1. So minus 1 times minus 1 is going to give us a plus 1 as our coefficient. And then looking at the surds, root 2 times root 2 is root 4. Okay, so we now have our expanded form. So what are we going to do to simplify this? So let's go through and look if we can simplify anything easy. So I can straight away see my root 100 is the same as 10. I can also see that my root 4 is the same as 2. So we can rewrite that as 1 times 2 over here. And we can also say that's 9 times 10 over here. So that's a 90. And this over here is 1 times 2, which is a plus 2. Okay, so let's go through and do these middle ones now, because again they both have a root 20. So minus 3 on the number line. So here's 0, 1, 2, 3 down here, minus 3. And because we're going minus, we're going towards negative infinity. So it's 1, 2, 3 down here. So we end up more negative with a negative 6 root 20. Okay, so this thing here, all of these numbers would be our answer. But first, we just want to make sure that there are no squares that go into that 20. Now, straight away, I know that root 4 times root 5 equals 20. And root 4, remember, is a square number. So we can rewrite that root 20 as 2 times root 5. Now I know that this root 5 can't be taken down anymore because 5 is a prime number. So this middle term then becomes minus 6 times root 4, which is 2, times root 5. Okay, and then I know, you guys will know, that minus 6 times 2 is minus 12, and then adding on this root 5. Okay, so adding this bit back into here, we get our final answer. Now this here would still be right, but it would not be in its simplest form. If we want the simplest form, we would write this. So we have our 90, we have our minus 12 root 5 now in the middle, and we have our plus 2. So can we simplify this anymore? Yes, because we've got one more lot of like terms over here. So we're going to end up with, as our final answer, 92 minus 12 root 5, because we put these two together and then we're adding this bit on the end. So that's our final answer there.